Hello students, I'm recording this video for anyone who misses the lesson. Today we're starting the next unit in pre-calculus, and the unit title is Rational Functions, and as part of the introduction we're going to talk about something called limits, and limits are a really big deal in calculus, so this year we're just getting an introduction to them and kind of getting our feet wet. We're also going to be talking about asymptotes. And asymptotes are something that you may have learned a little bit about in Algebra 2. And for Mrs. Zimmer students in the year 22-23, this, I believe, is notes number 25. So, students in class were given a notes handout, a little booklet, and they can just write their notes on the booklet as we go through the lesson. And for you, if you're watching this from home, if you have a printer, I did attach the notes handout to the Canvas page, so if you have a way, you might want to print out those notes so you can just fill in the blanks as we go. Okay, I also might divide this video into a couple of parts because it'll probably be too long for just one recording. So here we go. Number one, you have a graph that should look pretty familiar. It looks like a cubic function. And the domain would be all real numbers, so we can write all real numbers, or if we'd like, we could write negative infinity to infinity. And the range is also all real numbers, negative infinity to infinity. You can see that it goes through all of the x values, all of the y values. Now, the next part says, as the x values approach infinity, the y values approach blank. So let's see what the graph is doing. As the x values approach infinity, so x's are going this way to the right, what are the y values doing? Well, looking at the graph, you can see that the y values are just going up infinitely high. So the y values are approaching infinity as well. This whole idea of finding what y values get close to when x values do a particular thing is known as a limit. And limits have notation. We abbreviate the word limit. We write LIM. Underneath, we say what x is doing. So we say the limit as x approaches infinity. And then it's the limit of what? Well, what are we looking at as x approaches infinity? We're looking at y, or we're looking at f of x. So you can put the name of the function right here. F of x is the y value of the point, just like y is the y value of the point. And what does that limit equal? Well, we already discovered that the y values are heading toward infinity. So this part of the notation tells you what the y values are doing, as this part of the notation tells you what the x values are doing. So let's keep going. And we'll find some more limits for this graph. In fact, I might change my view just a little bit so we can see it all at once. As the x values approach negative infinity, the y values are approaching what? So now the x values are going out this way toward the left, infinitely far, and we see this graph is going down, so the y values are approaching negative infinity. And so the limit notation would be the limit of f of x as x approaches negative infinity is negative infinity. Okay, this tells you what the y values are doing. This tells you what the x values are doing. And I want you to notice how I say it out loud. On the next one, when I say it out loud, I'll repeat it and you can say it along with me the second time, okay? So here's the next one. As the x values approach 0, the y values approach blank. Well, looking at the graph, we want to know what's happening as the x values approach 0 from the left and from the right. So what are the y values getting close to? They are getting close to 2. As the x values approach 0, the y values approach 2. And our limit notation would be the limit of f of x as x approaches 0 is 2. So say that with me. The limit of f of x as x approaches 0 is 2. Very good. Okay, notice for the next couple of parts, I've taken out the words and just written the limit notation. So the next one says the limit of f of x as x approaches 2. Well, let me clean up my graph just a little bit. Okay, I had so many arrows drawn on there, I needed it to be a little more clean. Now we want x to approach 2. So coming at x equals 2 from the left and from the right, what are the y values doing? So the y values are coming down toward a height of 0 and coming up toward a height of 0. So the y values are getting closer to 0. So the limit of f of x as x approaches 2 is 0. Let's get rid of those little arrows and do the next one. The limit of f of x as x approaches negative 3. Okay, so x is approaching negative 3 from the left and from the right. What are the y values doing? Let's see. Looks like, if you look right there in that neighborhood where I've circled, it looks like the y values are getting closer to negative 2. So that limit would be negative 2. Okay, let's see what's on the next page. Okay, here's a new graph. So this is an example of what a rational function will look like. Number 1 was a polynomial function. We've just been studying a bunch of those. Number 2 is a rational function, and we'll get into that more and more this week and then after the break. So let's look at this. The domain. It looks like the graph does not have a point for an x value of 1, but it does have a point for all the other x values. So one way to list the domain is to say that x is not equal to 1. Another way would be to say that the x values go from negative infinity to 1, union 1 to infinity. Notice the open brackets not including the 1. And the range. It looks like the graph hits all the y values except for 2. So we can say that y is not equal to 2, or we can say that y is an element of the interval from negative infinity to 2, union 2 to infinity. So the first way is kind of a shortcut, simple way to write just what y is not, and the second way is probably a little bit more preferred, a way to write what y is. Okay, now let's evaluate some limits. So the limit as x approaches infinity. Okay, so x is approaching infinity, x is going out this way. What are the y values getting close to? It looks like the y values are getting close to 2, so that limit is 2. The next one, the limit as x approaches negative infinity. So the x values are going out this way. What are the y values doing? It looks like they're getting close to a height of 2 as well. So both of those are 2. Now notice the dotted line that I drew in, and notice that the graph is getting infinitely close to that dotted line the further out you go. Maybe you remember from Algebra 2 a time when you learned about an asymptote. This word here is asymptote. We don't really pronounce the P in that word. An asymptote is a line that the graph gets infinitely close to the further out you go. In this case, this line is horizontal, so we call this a horizontal asymptote, and I like to abbreviate that HA. So the equation of that line is y equals 2. Make sure you write y equals 2 and you just don't write 2, because you need to write the equation of the line. The line is horizontal. Every horizontal line has an equation of y equals a number. Okay, now there is a misconception. Some graphs have asymptotes that are crossed. For example, this sort of thing, this graph, it's getting infinitely close to its asymptote the further out it goes, but it is crossing its asymptote. Another example, you could have something like this, where you're getting close to your asymptote the farther out you go, but at some point, maybe you do cross it. So in Algebra 2, you might have learned that you can't cross an asymptote. That's actually incorrect. Some graphs do cross their asymptotes. So just modify that definition in your mind. Okay, coming from the left, as the x values approach 1, the y values approach what? Coming from the left. Coming from the left, as the x values approach 1. Okay, so here's 1. Coming from the left, look what the graph is doing. It's going down toward negative infinity. But we're only looking at that one side. And when we only look at one side, we have a one-sided limit. And here's what the notation looks like. The limit of f of x, let's see, did I call this one f of x? I did, okay. The limit of f of x as x approaches 1 from the left is written as 1 with a little minus after it. And we just discovered that that equals negative infinity because those y values are getting infinitely low. Coming from the right, as the x values approach 1, the y values approach what? Well, that would be this part up here. The x values are getting close to 1 from the right, but the y values are going infinitely high. So they're approaching infinity. So that limit looks like this. The limit of f of x as x approaches 1 with a little plus after it. So you have a little plus after the number or a little minus after the number when it's a one-sided limit. And that one equals infinity. And notice that the graph has a vertical dotted line drawn in, and the graph is getting closer and closer to that vertical line as you get closer and closer to x values, or as the x values get closer and closer to 1, the graph is getting closer to that vertical line. So that's known as a vertical asymptote, or a VA, and the equation of that line is x equals 1. Okay. I think that we should do one more of the problems and then probably start part 2 of the video. Okay, this time we're given this graph. Now, when you look at the part on the right, it was meant to be kind of smooth with a hole in it. It wasn't meant to look like two different sort of curves. So I apologize for that. That's just my drawing ability. Find the domain. Okay. Well, it looks like there is no point with an x value of -2, and there is no point with an x value of 3. So let's say that x is not equal to -2 or 3. Find the range. Are there any y values that the graph doesn't go through? It looks like the graph does not go through a y value of -2 or a y value of 0. So y is not equal to -2 or 0. I'll just write it like that to save myself a little space because I don't have much room there. The limit as x goes to infinity. So as x is going to infinity, the y values are approaching 0. The limit as x goes to -infinity. As x goes to -infinity, the y values are approaching 0. By the way, we could jump down to the bottom of the page. What's the horizontal asymptote? What line is that dotted line I've drawn in? That's the line y equals 0. And notice that as x approaches infinity, we get a 0. As x approaches -infinity, we get a 0. And the horizontal asymptote is y equals 0. Those are all the same. Those all go together conceptually. The next one says the limit of f of x as x approaches 3. Well, let's see. When x approaches 3, what are the y values doing? They're getting closer to a height of -2 from the right and the left. There's a hole in the graph, so they don't actually reach -2, but that's okay. The point is they're getting closer to a height of -2 as you get close to that x value of 3. The next one says, as x approaches -2 from the left, what are the y values doing? So as x approaches -2 from the left, the graph is going up toward infinity. The next one says, what's the limit as x approaches -2 from the right? So as the graph approaches -2 from the right, the y values are going down toward -infinity. So what's the vertical asymptote? Look at that vertical dotted line that I've drawn in there, and its equation is x equals -2. And notice what corresponds here. This limit and this limit correspond to the vertical asymptote, whereas this limit and this limit correspond to the horizontal asymptote. Okay, this is a great place to pause the video, and then we'll have part 2, a second video, to start us off with number 4.